Imagine AI-driven robots being able to manipulate our environment with the same ease as a human. Now this reality is closing in, thanks to the groundbreaking work of researchers from Carnegie Mellon University and Meta AI. They have developed a new approach, dubbed hybrid actor-critical maps for manipulation, called Hackman for short, which tackles a significant challenge in robotics, which is non-prehensile manipulation, a suite of tasks that extends beyond simple grabbing and gripping. Non-prehensile manipulation, like pushing, toppling, and sliding, is a skill humans take for granted, but for robots, it's a massive hurdle. Especially in environments where objects are difficult to hold or spaces are cramped, these subtle interactions are crucial. Despite extensive research, current techniques struggle to address the complexities of object geometry, tactile feedback, and sequential decision-making in such tasks. But what if robots could master these nuanced manipulations? That's the question that led to the creation of Hackman. This innovative reinforcement learning strategy is designed to perform complex non-prehensile tasks and generalize across different object geometries with adaptable interactions. It offers an exciting solution, using point cloud data to inform the manipulation process. The magic of Hackman lies in its two significant technical advancements. Firstly, it offers an object-centric action representation that's both temporally abstracted and spatially grounded. This means the robot decides where to make contact, then selects motion parameters for its next move. The position of contact is informed by the point cloud of the observed object, giving the action a firm geographical basis. However, this process results in more temporally abstract decisions for the robot. The second breakthrough is the incorporation of an actor-critic reinforcement learning framework to enact the action representation. Here, the action space straddles the discrete continuous divide. Motion parameters are defined over a continuous space, while the contact location is determined in a discrete space, choosing a contact point among those in the object point cloud. This unique setup enables Hackman to predict key values at each pixel over the object point cloud, with the actor network generating continuous motion parameters for each pixel. The results are impressive, with Hackman boasting a success rate of 79% on unseen, non-flat objects in simulations, proving its ability to generalize well to unseen classes. The success rate during training was more than 3 times higher than the best baseline, demonstrating Hackman's superior performance. But the researchers didn't stop at simulations. They took Hackman into the real world and used zero-shot sim-to-real transfer to test it on actual robots. The results were equally encouraging, with the robots demonstrating dynamic object interactions across unseen objects of varying shapes and non-planar goals. However, like all innovations, Hackman isn't without its challenges. It relies on point cloud registration to estimate object goal transformation, and camera calibration needs to be fairly accurate. Plus, the contact position is limited to the visible part of the object. Despite these limitations, the team is optimistic about the potential of Hackman, and they envision expanding the approach to include grasping and other non-prehensile behaviors. Meanwhile, in today's rapidly changing world, the way we consume news has become chaotic and overwhelming, and it's hard to get a well-rounded view on important issues, which is why we're really excited about Ground News. Their website and phone app help you easily navigate the news of the day. Plus, you get access to over 50,000 news sources in one place, allowing you to compare articles, spot media bias, check your blind spots, read global coverage, customize your feed, and understand your reading habits. For example, let's take a look at this latest news story about the World Health Organization's comments on bias and misinformation as it relates to the use of AI in healthcare. Here you can see the number of sources reporting, the distribution of bias, factuality, and even the ownership of the news outlets. You can also compare headlines to see how every side is reporting on the story. By using Ground News, you can become a more informed reader and understand the nuances of the stories you're reading. So don't miss the opportunity to get a balanced and comprehensive view of the news. Click on the link below to try Ground News for free, or become a subscriber to unlock unlimited access. Meanwhile, a recent breakthrough is making conversation with an artificial assistant feel as natural and dynamic as chatting with a friend. This is the future Google is working towards, employing reinforcement learning to make human assistant interactions more engaging and goal-oriented. This isn't just about giving a single answer, but rather about conducting a multi-turn conversation that adapts in real time, So check out how Google achieved this edge in human-like performance in its mounting struggle for AI dominance. The journey to this more interactive future is not without obstacles. Crafting a large-scale dialogue system that can implement RL in real-world settings is a formidable challenge due to the sheer complexity of modeling, immense state and action spaces, and the nuanced design of reward functions. Google's answer to this lies in the heart of the assistant response mechanism, a dialogue manager that uses off-policy reinforcement learning. Here's where things get interesting. To overcome the issue of a large state space, Google relies on the magic of supervised models like recurrent neural networks and transformers. They fed the dialogue history, turning it into a sequence of user and assistant interactions. In return, they spit out a representation of the dialogue state in a compact, effective latent vector. That's right, even the entirety of your conversation history can be condensed into a tiny vector. But what about the unbounded action space, the potential infinity of words or sentences the assistant could use? Here, Google innovates again. They limit the action space to a set of reasonable responses that content providers generate at each conversation turn. With this, the action space changes with each state, moving us into the realm of stochastic action sets. Google tackles this using a variant of key learning called stochastic action key learning, a popular off-policy reinforcement learning algorithm that doesn't require an environmental model to evaluate and improve the policy. To put this all to the test, Google conducted an experiment using Google Assistant to chat with users about animals. They compared the RL Dialogue Manager with a supervised transformer model. The results? The RL Dialogue Manager led to longer, more engaging conversations, increasing the conversation length by 30% and improving user engagement metrics. In response to the assistant's questions, cooperative responses increased by 8%. More intriguingly, the reinforcement learning assistant was found to take more conversational risks by asking pivoting questions. The real beauty of the reinforcement learning-based assistant lies in its dynamic planning capabilities. The assistant ended 20% more turns with questions, inviting the user to choose additional content. It also effectively harnessed content diversity, using 26% more distinct content providers per conversation than the supervised model. Furthermore, the RL assistant was more inclined to engage in sub-conversations that are rich in content, selecting 31% more fact-related content. To illustrate these advancements, consider two example conversations about animals. In one, the supervised model pivots back to animal sounds after the user declines to hear about today's animal, aiming to maximize immediate user satisfaction. However, the RL model employs a different strategy to optimize overall user engagement, introducing more diverse content like fun facts. Overall, the future of AI-assisted conversations is here, and it's looking more human-like than ever before.